All right, so we're recording. So the agenda for this session is going to be, I'm going to do a quick introduction to JSON. I know probably most everybody's familiar with JSON at a high level, and probably everybody's pretty familiar with JSON at a very deep level, but it always helps to get a quick refresher. And then, and the reason for that is because Spinnaker heavily uses JSON both in the backend and in the UI, and it's very helpful to get, have a good sense of what works in JSON and what doesn't work, things like that. We're also going to talk about artifacts and the different types of artifacts and the different ways they're used within Spinnaker. And I'm going to do a quick demo of artifacts. I don't have currently a lab set up, but I do have in the training environment, I have a number of artifact pipelines you set up, so you can go in and take a look at those and copy those and use those in your own pipelines or in your own training application. So welcome to use that. And then we're going to do the same thing with SpEL. So I have a couple of concepts for SpEL, some of the high level what SpEL is, what it's used for, why you would want to use it. And then I have a couple demos and examples of how to use that. So first things first, we're going to talk about JSON. And so most everybody probably knows that JSON is comes from JavaScript object notation. It is a language / syntax / API kind of, but not really, for presenting and storing data, right? And so the key part here is that Java has objects, or sorry, JSON has objects. Objects have key value pairs in them. So an object can have one or more key value pairs. The keys are always a string. The values can be a string, a number, a Boolean, a null object, or they can be a nested object or an array of objects. And so this is very useful when you're working with Spinnaker. You're looking at Spinnaker and you see, okay, I'm looking at this object within Spinnaker, and I need this bit of information that's in my Spinnaker pipeline, and I need to know how to access that, right? So you need to be able to navigate the JSON tree structure and identify how we get to a specific field. So for example, if this is my JSON stage definition or my stage information, cloud provider type, to access that, assuming we have top level object of X, then the .cloud provider type would be right here. This would be my AWS. We can potentially access nested parameters or nested fields. So .extended attributes, .static packages would be the static packages object, which is a child of extended attributes. Then we have maybe we can grab an array. So this is an array of two objects or an array of two strings, which is regions. And then we can individually access different fields within the array. So and these are 0 index. So the first item would be index 0, regions 0. The second item would be regions 1. And then another thing that's very useful for when troubleshooting Spring expression language and sometimes artifacts is that if you try to access a field that doesn't exist, you're going to get an error, right? And that's most of the time when you see errors with Spring expression language and Spinnaker, with SpEL and Spinnaker, it's probably because you're either accessing a field that doesn't exist, or you're accessing a field and expecting it to be one type, and it's the wrong type. So maybe you're accessing a string and expecting it to be a number, or you're accessing a Boolean and expecting it to be a string, or you're accessing a field and it doesn't exist. So those are pretty common things that you'll see when you're working with SpEL and Spring expression language and Spinnaker. And then let's talk a little bit about artifacts. So Spinnaker artifacts kind of get a bad reputation within Spinnaker, partially because they are actually relatively confusing, right? And so maybe 6 months or a year ago, there was a big project in the Spinnaker community to overhaul the Spinnaker artifact UI. And depending on what version of Spinnaker you have installed and what how you installed it, you may have the old new UI or the new UI. I would say if you are running Spinnaker, you almost always want to be on the new UI, right? It's just much better. And this is how you turn it on. You use this, if you're using Halyard, you say how config features edit artifact rewrite true. If you're using operator, there's an equivalent flag. If you're not using Halyard, I think you go into deck, and there in your settings.js, there's a equivalent flag that says turn on the artifacts rewrite. And it basically makes the overall process for working with artifacts much easier. So I'm going to talk about some of the artifact concepts, and then I'll explain why the new UI is better. When you're working with artifacts, artifacts are generally either internal or they're external. Most artifacts are actually external. So an artifact is a reference to, an external artifact is a reference to something that lives outside of Spinnaker. So this could be a Docker image. This could be a Kubernetes object. This could be a Git repository. This could be a file in GitHub or an S3 or an HTTP artifact, or it's internal. And the internal is usually used to pass information from one stage to another. So this could be, for example, if I have a Kubernetes bake stage that's taken a Kubernetes Helm chart and turned it into a manifest, we need a way to pass that manifest from stage A to stage B, and we'll use base64 for that. There's a couple different ways you can have, you can generate artifacts or create artifacts. One of those ways is you can have the artifact populated by a trigger. So if you have a webhook trigger that is triggering your Spinnaker pipeline, or if you have a Git trigger, or if you have a Docker image repository trigger, you can have Spinnaker trigger off of that. The alternative is if you have a static element, so say you have a manifest that lives in a Git repo that the manifest doesn't change, but it is parameterized, then you can have a static artifact referenced from your Spinnaker pipeline. And this is where the old UI versus the new UI comes into play a little bit. With the old UI, every artifact defaulted to dynamic, and then it did not have a super intuitive way to specify the static version. So for example, if you set up an artifact in the old UI and said, I have to pull in a Kubernetes manifest from a Git repository, then you would specify, you would have to go to the high-level configuration for your Spinnaker pipeline, create the artifact, there, specify that you want the default, and then pass that into the Spinnaker pipeline later on. And with the new UI, all that's easier. So I'll show everything in the new UI. I'm not going to worry too much about the old UI unless you want to see it. There is a question in the Zoom chat. Can an RPM or a list of RPMs be artifacts? The answer is you can refer to files outside of Spinnaker, and I think you can actually refer directly to RPMs. But it kind of depends on what you're looking to do, right? So if you're just passing around a URL or like information about an RPM, it doesn't necessarily need to be an artifact. It could be. You just have to find the right use case there. And actually, I think it may be worth taking that chat offline, AJ. But I'm happy to chat about that because it's actually a fairly complex topic. Continuing with the slide, a Spinnaker artifact can either be used by stage or consumed by stage. So if you have a manifest, for example, and you're deploying that to Kubernetes, you're consuming that manifest. You can also produce an artifact from Spinnaker. So you can say, I have a Helm chart that I'm baking into a Kubernetes manifest. So that would be producing a manifest. And then if you have a stage that is producing that manifest or producing an artifact, that artifact will likely also be consumed. So it's both consumed and produced. And then there are a number of different artifact types, right? So, and the reason part of the reason artifacts are so confusing is that these are used in so many different ways. So these are the high-level ways. There's a couple of ones that I didn't mention, but these are the ones you probably see the most often. So the most common ones are provider object or API file. So this is like HTTP file or GCS object or S3 object or GitHub file. And these are usually used to reference some file that lives somewhere, right? So this can be a text file, such as a manifest. This can be a Helm chart, which is a tarball. This could be something else. This could be used to reference an RPM, and then you just have to figure out how to use that. The next type is the embedded base64. So if you have a Kubernetes manifest that gets generated by one stage and then is consumed by a different stage, then you pass that between those two stages as an embedded base64 artifact. You have the Docker image artifact, which can be used in a Kubernetes manifest to dynamically replace the Docker image, and can also be used in a couple of other places. So ECS is an example of this, and I'll show a little bit of this. There is the Git repo artifact, which is used to reference a Git repository. And this is currently only used for customize and then also a custom Armory feature. But basically, because customize expects a set of files rather than a single file, this will do an actual git clone rather than just grabbing a single file. And then the Kubernetes kind artifact is basically a way to reference a dynamically generated Kubernetes object. So I'm going to talk about each one of these and show a couple of examples. So the first type is the provider object or API file. And provider can be one of S3, GCS, AZS. API can be GitHub, Bitbucket, GitLab, OCI, I think, HTTP. And these are usually used to reference either a Kubernetes manifest or a Helm chart, but can theoretically be used to reference any file. And then the way you get these into your Spinnaker pipeline is usually one of two ways. You either pass them in as a trigger, and then if you're passing it in as a trigger, you want to match that artifact. I'll talk about what that looks like in a little bit. And then the way you actually use these is you specify that you are deploying this artifact rather than a manifest, or you are baking an object, baking a Helm chart, baking a customized, or not customized, but baking a Helm chart using this artifact. And then, let's see, I had these in a different order. All right, well, we'll do both of these. So the second object type is a Kubernetes kind. Kubernetes kind is basically used to pull out a dynamic Kubernetes reference from one stage and use it in another. So one of the things that Andrew mentioned earlier was if you have a dynamically generated Kubernetes config map where it's versioned and you need to use that version in a later stage, you can have the first stage. So you deploy a config map in one stage, could use that config map in a replica set in a second stage. You can have the first stage produce an artifact that is a reference to the config map, and then you can use that config map in the second stage. Let's see. And let's see, I'll just go do a demo now. So let me show you what this looks like. All right. In the Spinnaker training environment, if you go to the JLE workspace application, probably should have called it something else, but it's okay. I have a number of artifacts pipelines, and I'm going to show you what this looks like. So what I have is, if, for example, I have a artifact that lives in my Git repository. So in this case, I have in the GitHub Spinnaker hackathon training artifacts in SpEL. I have a config map that I'm going to access via the GitHub API. And I also have a deployment manifest that I'm going to access via the HTTP API. And so I say, I'm going to deploy an artifact. So I'm going to show you what it takes to actually set this up. So I'm going to go in and say, actually, I'll set this up in parallel. So I'll show what it looks like to set this up. So I go to pipelines. I'm going to create a new pipeline called config map replica set. And then I'm going to do this relatively quickly because we do have a relatively limited amount of time. Let's say I want to deploy manifest. So I'm going to say deploy manifest. I'm going to deploy to Spinnaker and deploy to the namespace Justin R. Lee. I want to reference a static artifact. So I'm going to say a static artifact, define a new artifact. We're going to use the GitHub API to get to this. And I have to have the GitHub API path. So this is not just copy pasting this URL. This is actually generating an API path that is api.github.com/repos, and then your repo name, and then contents, and then the file path within your repo. And then you can specify things like a branch. And what this will do is that this will deploy my config map from my Git repo. And in this Git repo, I have a dynamically generated field. And so what this does is every time I actually deploy this, it's going to be a new replica set or a new config map. And so when that happens, I want that to generate a Kubernetes artifact for me. So I'm going to say Kubernetes. It's going to be a config map. And the reference is going to be something like this. I'm just going to copy this over. My config map is called special config. And it's going to be dynamically generated with a postfix on it. So I'm going to say special config .star, save artifact. And I'm going to run this. All right, so I'm going to go here. I haven't actually set up the second stage here, but what this is going to do is it's going to deploy my config map. assuming I did that right, which, you know, sometimes I don't. And if I go in here, I can see that this generated a config map, and this has a version that is, it has a dynamically generated version, right? So if I go to the actual name of the config map, it's called special config v004. And so if I directly reference my config map in my deployment manifest or my replica set manifest, I like to call this the deployment, it's actually replica set. Excellent. Anyways, so if I deploy this directly without using artifacts, then this would try to use a replica set that does not actually exist, right? Which is not great. So what I need to do is I go back to my Spinnaker pipeline. I've told Spinnaker to output, to grab the replica set, or grab the config map that is called special config and has something after it. So that's using regex. And then I'm going to go deploy my Kubernetes manifest. There's a question from Xiaosheng in how do you provide keys to access the API? This is configured in the back end of Spinnaker. So there is, Alice talked a little bit about halyard and a little bit about operator, but basically in the backend configuration for Spinnaker, there is a set of, here are the credentials that Spinnaker has access to. And there's basically a way to dynamically configure this so that you can add GitHub credentials or SSH keys or S3 credentials or whatever you want to do. So this is configured in the backend. You don't have, it's not accessible in the training environment. So I'm going to say, I'm going to override the namespace again, deploying to Justin R. Lee. I'm going to deploy an artifact, and this time I'm going to do a HTTP artifact. And so in this case, I'm going to say I'm going to use this HTTP URL, which does not require credentials. And then I'm going to do this, required artifact to bind, fluffy insect2. And so I'm going to save that, and I'm going to show you what that means. So if I go here, and I go look at my artifact, this creates an artifact called fluffy insect2. So if you work with Docker, if you work with Docker, you'll see like when you do a Docker run, it generates a dynamic fun name for the artifact. This is basically that. It's just a randomly generated string that is used to reference the artifact. In the backend, this is actually sort of, you know, a UUID, but it's not very portable or human readable, so that's why we have the friendly name. And then what this artifact actually looks like in the JSON is that this artifact says we're looking for a Kubernetes config map that references special config. And then if I go look at the actual execution of this when it ran, it generated a config map that is called right here. Generated an artifact that has the name special config and it has a reference special config v004. So what that allows us to do is in my deployment manifest or my replica set manifest, it's actually going to dynamically, it's going to look for a config map reference that's called our special config. And it's going to replace that with a field from my artifact. So it's basically doing a little bit of magic to say, detect the generated config map and deploy, and then reference that, or detect the deployed config map and then reference that in our pipeline. So I'm going to save this, or this is already saved, and I'm going to run this. So what that does is it generates a dynamic config map on the first deploy. So that should take a second or two. And if I go look at the artifact, I can see the artifact. I can also see that this has a v005 on it. So somewhere in here in the name, which I can never quite find, special config v005. And then if I go to the deployment of my replica set and look at this, we can see that the actual reference to the replica set has been updated with special config v005. So this is a way to basically pair together your items. You don't want to, one of the patterns here is you don't want to actually overwrite a previous config map. You actually just want to have a new config map and then reference that unique config map in your deployment. And this is very helpful when you want to do things like rollback. So if, for example, I go to my deployment and say, I want to roll back to this version, right? Each one of these references a unique config map, so I can just say, this is the version that I care about. And I can delete this one and then go back to this one, and this config map will, or this replica set will reference the correct config map that was deployed at the same time. This is how we have essentially immutable releases. All right. So that's one set of artifact types. That's the Kubernetes kind, and then the provider and the object and a file artifact types. The next artifact is the base64 artifact. And the base64 artifact is basically a way to pass around a object between stage to stage that is internal to Spinnaker, right? So in this case, what we're doing is we're generating a Helm chart, or we're generating a Kubernetes manifest from a Helm chart, which is a big, large YAML file, and we're base64 encrypting that, which is, or base64 hashing that, not really encrypting it. And then we're going to pass that to a deploy stage. So we have two stages. We have the bake stage, which takes a Helm chart as an input and outputs a base64 artifact. And then we have a deploy stage, which takes a base64 artifact as an input and deploys that. There's a question, where does the base64 artifact get stored? These actually don't get stored in an external repository except for as part of the Spinnaker pipeline, right? So as you're going through Spinnaker, every Spinnaker pipeline execution is saved in history. Depending on your retention settings and stuff, all of this base64 is completely internal to the Spinnaker pipeline. It's not stored in a repository. It's not pushed to S3. It just lives in the pipeline. So as long as you have the pipeline information, then you still have the artifact. And if you delete the pipeline information, you lose the artifact. For this reason, you don't want to put credentials. This is generally not a good idea to put credentials in here. So there's kind of depends on what you're going to do. There's some things. I think Alice talked a little bit about vaults and about like better secrets management. Spinnaker does not currently have a way to handle application secrets in a secure way. There's things you can do to get around that, and I'll talk about that with the run jobs, but in the next session. But right now, this is base64. This is not encrypted. This is just hashed, and you want to be careful about putting secrets in here. Let's see what's the next one. See the other two. I think my next demo has both base64 and Docker image. So I'm going to talk about both. The Docker image artifact type is basically a way to dynamically replace a Docker image in a manifest. It can also be used to, if you're deploying to ECS, AWS ECS, which is like the container platform in AWS, then you can also use the Docker image artifact type for that. And so what this does is you have your Spinnaker pipeline that is either monitoring the Docker repository for new image tags, or you make an API call to Spinnaker and pass in your artifacts. And have the artifact be, a dynamic reference to a Docker image. You take that and then you pass that to your Kubernetes manifest, and then you deploy it, and it'll have your custom image or your new image, your dynamic image, rather than the static image of the manifest. The other option is to use this for ECS task. I'll do Git repo in a second after that. So if I go back over to my Spinnaker pipelines, I'm going to show you the so there's a question also, or Young added a question. Base64 artifact gets stored in pipeline, does not get deleted until the pipeline gets deleted. You can trigger off of a new Docker image that gets pushed to ECR. And so what you would do for that, and I'll show you what that would look like. I'm not actually going to set it, but I'll show you what that looks like. If I go into this Helm chart, or the Helm chart pipeline, you say there is, in the Spinnaker configuration, there is a section for setting triggers. So you could say, I want to trigger this Spinnaker pipeline every time it receives a specific webhook on a specific endpoint. Or I want to trigger the Spinnaker pipeline every time I receive a Git push or a Git PR creation. Or I want to trigger the Spinnaker pipeline every time a Jenkins job runs, right? So in these cases, Spinnaker would need credentials for your Git repository, or it would need your credentials for your Jenkins instance. Or what you could say is, I want to trigger the Spinnaker pipeline every minute or every day or every, everything on some cron schedule. And this supports cron syntax. And then there's a number of other artifact trigger types. And so some of these will pass in artifacts. In this case, what I have is I have this configured to say every time there's a new Docker image, push this to this Docker registry, then we will run the pipeline. And when that happens, we will also receive that artifact. Or Spinnaker will generate the artifact JSON. So all artifacts are JSON. We'll generate the artifact JSON, and then I just realized I missed something. It'll generate the artifact JSON and then pass that into the Spinnaker pipeline. So yes, you can trigger off of receiving a new Docker image, and this will also say, you can also say, I want to create an artifact. So this is looking for an artifact that looks like this. All right. One thing I actually forgot to include in this, and I apologize. I'm going to show you this Spinnaker pipeline JSON. So an artifact looks like, I should have started with this. Spinnaker artifact looks like this. So a Docker image artifact looks like this. Every artifact has a type, every artifact has a name, every artifact, or most all artifacts have a reference, and then there's a number of other optional fields. So every artifact in Spinnaker is stored as JSON within the Spinnaker pipeline. If you're looking at base64, then actually I'll show you base64 in a little bit, but most of these are just references to external things. So you have, for example, types. If you go to types of artifacts, this is what a GCS artifact will look like this. It's a reference to a file in GCS. You could have an HTTP artifact that looks like this. It's a reference to an HTTP file. Kubernetes object looks like this. It's a reference to a Kubernetes object, so Kubernetes deployment, config map, replica set, secret. And you have things like reference and namespace and everything that has all the information that's necessary to refer to the artifact. And then the base64, the reference actually has the base64 in it. All right. So what I have in the Spinnaker pipeline is I have this will, when I run this pipeline, so there's a couple ways you can trigger this. One of them is I've set this up to trigger every time there's a new Docker image, my Docker image repository. Or I could just select a drop-down item, and I'll show you what I'm actually going to use that. And then I also have a Spinnaker stage, a bake manifest stage, and this is basically used to do a Helm bake or a customized bake. I'm using Helm 2 in this case. I have a Helm chart that lives in my S3 bucket, and so one of the things with when doing Spinnaker with Helm is that Spinnaker, when you're working with Helm, only requires that your Helm chart lives as a tarball. Right, so Helm charts are packaged as a tarball or archived as tarballs. There's a way around this. I'll show this in the next session. But for right now, we have a Helm chart that has been pushed to S3 that is accessible via HTTP. So it's a public S3 bucket in this case. You can provide things like I want to provide a values override. So I'm going to reference a values file that lives in S3 or in GitHub or somewhere else. And then you can also override individual things. So when you're doing like a Helm template, this is going to do a Helm template under the hood. You can pass in values file dash values with a values file, or you can pass in dash set, which is individual overrides. And Spinnaker allows you to do the same thing. And again, this is going to do a Helm chart. It's going to pull down the Helm chart. It's going to do a Helm template, and then it's going to generate a Kubernetes manifest. And so what I have is I'm going to generate a base64 artifact. So you see the type base64 embedded artifact. We're going to call it chart. And then if I go to my deploy manifest, when I go to deploy, I'm going to say I'm going to deploy that manifest. So I'm going to deploy the base64 manifest that was generated by the Helm chart. And then I'm also going to override the Docker image with my Docker image artifact. So this is Jolly Tree Frog. This is my Docker image artifact. We have oddmoose is my base64 artifact. And I'm going to deploy oddmoose, which is my base64 Kubernetes manifest, with the Helm chart with the Docker image override. And so I'm going to run this, and I'll show what this looks like. So if I do start manual execution, I'm going to specify one of the tags. So I have a tag called let's go with Saturday. So I'm going to run this, and this is going to do my Helm chart. So on the back end, what this did, it was this reached out to my S3 bucket, I think, or my S3 bucket where my Helm chart lived, and generated a Kubernetes manifest. Notice that the image does not have a tag on it. So this generates a base64 chart. And then we go look at the deploy. It consumes the Docker image coming from this Spinnaker pipeline, which is also visible here. It consumes our base64 Kubernetes manifest, which was generated by the Helm chart. And it generates a Kubernetes manifest using the 2 and deploys it. So if I scroll down, you'll see that it actually replaced dynamically my Docker image. And so the way that works is if I actually look at the artifact, what the artifact looks like, the Docker image. So it has a name of index.docker.io/justinlee/nginx, and it's going to look for a Docker image in the Kubernetes manifest that has this name, and it's going to replace it with this. which is the fully qualified reference. So that's the Docker image and the Helm chart and the base64. All right. And then the last artifact type that I'm going to talk about is the customized Git repo artifact. So right now, when you're using customize from Spinnaker, customize operates against essentially a directory of files. So there's the chart.yaml, or there's a customization.yaml, and a number of other child files that are referenced in that customization YAML. And so instead of expecting that to be a tarball or a zip file or something, Spinnaker will do a git clone of that directory or of that repo and change it into a directory and then operate against it. And again, this can be produced by triggers. So you can say, trigger this off of something, or you can have it statically defined. And so I'm going to show you statically defined. And then again, this is used by the bake manifest stage. So if I go back over here, go back. So I have a customized Spinnaker pipeline, and it looks like this. And so in my bake manifest, rather than specifying a file, I have the Git repo account. So this is an account called Git repo, which is essentially a GitHub credential. Actually, no, a Git personal access token, so a Git credential. We're going to be using customize instead of Helm. We're doing a Git clone of this repository. This is a public repository, so if you want to see that, it looks like this. I have a customized template in here that's just a customization with a resource and then a patch in it. We have a branch. We specify we're working in this directory. We're specify we're doing this customize. This is where our customization file is. And then this is basically going to do the same thing as the Helm. So it's going to take this. It's going to pull down the Git repo instead of the Helm chart. It's going to do a customized build in that directory using that customization file. And it's going to generate a Kubernetes manifest, and then it'll also deploy that. So when I run this, this is what this looks like. So I do this, I can look at this and see this is the manifest that was generated from my customization. So it's a very simple manifest, right? And then that'll get deployed, and it'll do our deployment. And so that's artifacts. Let me show you this actually. I want to show you the old artifacts UI. I know we're kind of running up on time, but no, I have the next session, so that's okay, I guess. This is the old artifacts UI. So in the old artifacts UI, if I wanted to create a reference to let me see, I think I have a Helm chart in here. Helm big workspace. Helm. This is what it used to have to look like. So you actually had, rather than specifying the Helm chart in the bake stage, I actually had to go to the configuration stage. I had to create expected artifacts, and then I had to create a default artifact and reference that. So you had to know ahead of time where your artifacts were. You have to decide if they're static or dynamic. You have to know that you had to specify this checkbox and actually put it down here rather than up here. There's this whole mess of what the match against does. So that's the old UI. The new UI is much better. But anyways, that is artifacts. And I guess I have about 10 minutes to talk about which is actually a pretty weighty topic as well. So this is the slideshow. So Spring Expression Language, or SpEL, as it's abbreviated, basically allows you to run snippets of Java in your pipeline. And it allows you to, and this Java has access to the rest of your Spinnaker pipeline. So you could say, I have, some bit of information that was generated in one stage, and I want to use that in a later stage. Maybe like a number, maybe like a string, maybe you want to do some logic there. This is evaluated at runtime, so you have your Java Spring Expression Language stuff, your expression in Spinnaker in the pipeline, and it gets evaluated when the pipeline actually runs. You usually want to nest it in this wrapper, so you have your expression in this curly bracket thing with a dollar sign in front of it. You can almost always operate against the existing Spinnaker pipeline JSON. And then there's a number of helper functions built into Spinnaker that make this easier to do. And so there's a lot of different ways you can use this. It's very powerful. Some of the more common use cases is you can use this for branching decisions. So for example, you can say only run this stage if this previous stage was successful, or only run this stage if this previous stage was a failure. Or you can say, I will only run this branch of the pipeline if this previous stage was successful, or if this condition is met. You can also calculate and evaluate expressions. So this allows you to say, I have some information that is present either within my Spinnaker pipeline or another Spinnaker pipeline or some external place, and I need to grab that and use that within my Spinnaker pipeline, and then save that as a variable that's usable for the rest of the Spinnaker pipeline. And then you can also specify and you populate essentially most any field within Spinnaker. And so two of the ways you'll see, two of the really helpful stages that you'll see a lot with this are the evaluate variable stage and the check precondition stage. The evaluate variable stage basically allows you to have a fairly complex SpEL expression and condense it down to a single variable, or condense down the value of that expression to a single variable at runtime, and then use it across multiple places. And it also has a nice UI for doing SpEL evaluation during pipeline development. And then there's also the check preconditions stage, which allows you to say, in this specific situation, I want to not run this branch of a pipeline. And I have a couple of examples of this. Something this over here. Oh, that's not right. So close this. Actually, I'll put this right back over here. So if I go to my pipelines, I'm going to close all of my artifact stuff. And I have, for example, one very common use case is that you only want to run a stage in a specific situation. And so I have two examples of this here. The first example of this is that I have a trigger on here, or I have a parameter on my Spinnaker pipeline, which in this case supports either the yes or the no option. And it says, do you want to run the first stage? Do you want, right? And then in my first stage, which is just a wait stage, but could be a deploy stage, could be a manual judgment stage, could be a test stage, whatever. So this is useful to say, I only want to run tests in my test environment, not my dev environment. Or I only want to deploy to prod if this branch does not have, or if this Docker image tag does not have -dev on it. In this case, I wanted to only run the wait stage if the first stage parameter, so parameter run first stage equals yes, is equal to the string yes, right? And then I also have a manual judgment. And this manual judgment, normally when you have a manual judgment in a Spinnaker pipeline, and if you click stop, it'll stop the pipeline. In this case, I say continue running the pipeline. And then I have a stage after this that depends on this manual judgment that says only run this stage if the manual judgment was approved, or if you click continue. And then separate from that, I have this other stage that will run regardless of what your manual judgment is. And so you can see workflows here where if you want to run a pipeline, if you want to always run the stage, regardless of what happens, then you run the stage. Or if you have other stages that you don't want to run or only want to run in certain specific situations, then you can use a conditional on expression and allow you to basically build out routing logic in your Spinnaker pipeline. So I'm going to run this a couple times just to show you the different behaviors. So first, I'm going to say, yes, I do want to run the first stage. It's going to run the first stage, and maybe I don't care that I can wait 5 seconds. So it goes to the management, and I say, OK, I actually do want to run both stages. So I'm going to continue. It'll run these 2 stages. And those are all just wait stages for now, but they could be any stage in Spinnaker. All right. And then the other option is I could say, actually, I don't want to run these stages. I don't want to run the first stage. So I'm going to say, no, don't run the first stage. It's going to skip the first stage and go straight to the manual judgment because I have that conditional. And then I say, oh, I also don't want to run the only run sometimes stage. So I'm going to click stop. And because I have that Spinnaker stage configured to run regardless of status, it'll continue on with the pipeline. And it will run the always run stage, but it will skip the only run sometimes stage. And so this is a little bit of a contrived example, but you can start seeing how as you start using more and more of the SpEL, you can start building out logic around what does the previous stage status look like? Did this test fail? Did this test succeed? Did this notification respond with success? Did my webhook to an external service pass? And then create logic all of that. And you can do Boolean logic and pretty much basic Java logic within the Spring expression language. So I could say, I also want to only do this if parameters dot first stage run for stage whatever equals true, right? So you can do custom logic there. Another use for Spring expression language. Actually, I want to show you just basic Spring expression language. So as you're navigating a Spinnaker pipeline, or as you're working with Spinnaker pipelines, every Spinnaker pipeline has this execution details source. And so this is JSON that defines everything that happened up until this point, and including, in this case, because the pipeline's over, at this point, what the Spinnaker pipeline looked like. And everything within this JSON is accessible within SpEL. So for example, maybe I need to know the stage ID, or maybe I need to know at what time this stage ran or was approved, or maybe I need to know who approved this stage. So this was approved by Justin Early or Justin Utley at Armory.io. And you can start using these bits and pieces of Spinnaker in your Spring expression language. So I'm going to show you what that looks like. So if I go into here, I'm going to add another stage, and I'll put it right here after the always run. And I'm going to use the evaluate variables. And the evaluate variables stage has a very nice preview function. So I can say, like, I want to gather some information. I want to do hello, and I'm going to do stage. I'm going to get information from my first stage, and it'll generate a preview. And I say I want to navigate down to the end time, and I'm going to do a toString, right? And then maybe I want to have a notification saying this stage ran at this time. So I'm going to do let's do a wait stage for now, because I like wait stages, but you could do a manual judgment, you could do a webhook, you could do something else. And now that I've generated a variable called hello, I can reference this. And so I could say previous stage finished at hello. Save my changes. Go back to my pipelines. I'm going to rerun this. I'm going to skip the first stage. I'm going to continue the manual judgment. So these will both run for about 5 seconds. And then evaluate variables, and I can see that this stage finished at this time. And then if I go to my wait stage, that information is available within a Spinnaker pipeline. So that's another simple but powerful use of Spring expression language. And again, everything within the Spinnaker pipeline is available in SpEL. There's also a number of other helper functions. So you may have noticed that I use the stage helper function. I could have also put this whole thing directly in the wait stage, but I do like to evaluate variables for narrowing it down. Just be aware that there are some reserved variables within Spinnaker. And then there's a number of other functions available. So I use the stage function, but there's also, for example, a root function. There's also, for example, the various toInt, toFloat, to conversions things. There's the current stage. There's the get information from an external source. There's all sorts of custom stages here. And this allows you to basically build out fairly complex logic within your Spinnaker pipeline. So one example of this is that you could have a pipeline that calls other pipelines and actually loops over an array. So, every time you see this array, do a for loop or a while loop. You can do some interesting things with this. There's a question from Xiu Liang. Sorry, I apologize if I pronounced your name. There's a couple different ways to define these. So there's the Spin CLI and Spinnaker, as Eugene mentioned. We are Armory, so we have some custom features that are Armory specific, which we can talk about, but I don't want to talk about today. And again, every Spinnaker pipeline is stored as JSON. So there's a number, like at the end of the day, Spinnaker pipeline is JSON. There's a number of ways you can get this JSON into Spinnaker. So you can use the API, you can use Spin CLI, you can use Armory features, you can use Spinnaker, lots of options there. But these are all just, everything is JSON under the hood. And within the JSON, you can have your Spring expression language. So I have my expression right here. I also have my various expression language syntax with all here, and this is all just living within the JSON. So hopefully that answers that question. And then I'm going to go maybe 2 minutes over. So I have one more Spring expression language example. In this case, I want to get information from an external source. So in this case, I actually want to get information about a Kubernetes manifest that's running. All right, so I have a Kubernetes manifest called Hello Today, and it's a deployment. It's deployed by one of my artifact pipelines. And I want to get information for that. So there's this stage that's called find artifacts from resource manifest. That'll actually just read the Kubernetes manifest into Spinnaker pipeline. Then I'm going to grab the number of instances, and then for fun, I'm going to multiply that by 5. And then I'm going to run a wait stage that is going to wait for 5 times the number of instances, because it doesn't really make sense, but the logic is, it works. And the idea here is you can use Spring expression language pretty much anywhere within the Spinnaker pipeline. So in this case, I'm using Spring expression language to get the wait time, and calculate the wait time based on the number of instances of a replica set. Right, so maybe you have some number of instances and you need to wait longer or something. So I have, I'm going to run this, and I'll show you what this looks like. So if I do SpEL manifest information, we're going to run this pipeline. The first stage is going to grab the Kubernetes manifest. And if I go to source, I can actually see the Kubernetes manifest in JSON, somewhere in here, multiple times in here actually. Then I have the evaluate variable stage, which says the number of instances in my held up today deployment was 2. And I'm going to run for 10 seconds. And then this is going to wait for 10 seconds. And you can see it actually just waited for 10 seconds, and then it had a comment there. So the idea here, and this is just a quick intro to both artifacts and Spring expression language, is that Spinnaker has a lot of flexibility and a lot of capabilities to do both custom logic and dynamic deployment, and combine all these different capabilities to build out some fairly complex and fairly advanced Spinnaker pipelines with whatever logic you want. And then going back to the discussion earlier today, you can treat Spinnaker as a platform that can interact with all of your external tools, that can interact with your clouds, that can do your deployments, and build out logic that maybe has all of the SDLC components that are relevant to your Spinnaker pipeline, or that are relevant to your deployment process. So I'm going to pause there. We're about 5 minutes over. And I think I've been answering questions as they've come up in the Zoom chat, but if there are any additional questions, please feel free to ask. Feel free to speak up. Otherwise, I think we're taking maybe a 5 or 10 minute bio break before we continue with the, I think the final session of the day. So any questions? All right, let's wait till the 10. Thank you very much, and I'll see y'all in a little bit.